how much of an issue microplastic has become recently. But the issue with stopping microplastic from becoming a further issue is I'm certain every single person in this room either has plastic on them right now or has had plastic on them at some point of the day. Because currently there aren't any sustainable or affordable replacements of plastic that are widely available to the public. So my project aimed to pinpoint the exact location within the marine food web in which microplastic most commonly enters. And I aim to see whether or not it started at the very, very base level and to see if phytoplankton had any impact on this. So my initial hypothesis was that if additional phytoplankton is present in a plankton sample with microplastic, then more microplastic will be integrated into the marine food web. And I also had this null hypothesis for consumption, but I'm not going to focus on that one for the most part. So for my methodology, I used 2 plankton nets. One of them was the one we used on the boat, which I used as a drag net to primarily collect zooplankton or animal plankton, while I also had my own dip net that I used to collect phytoplankton. I had a video microscope. I put the zooplankton into 2 empty petri dishes. In one of them I added phytoplankton, and in both I added microplastics. Then I left them for 30 minutes and then recorded whether they had eaten the microplastic, whether there was latching from the microplastic onto zooplankton, or whether there's latching onto it from phytoplankton. So I might go over because there's a lot of data. So my results from consuming were insufficient. I did a chi-square test, and I had a p-value of 0.15, which is above the threshold of 0.05, meaning that there's no scientific statistical significance, even though the mean value or the middle value of the one with in the experimental was higher slightly. It's not significant on a scientific level. However, it also needs to be addressed that due to the low amount of data I was able to take, that this may just be due to sample size, so further research is needed to see whether or not the consumption does have a difference based on additional phytoplankton at that level. I also do have some images that I took from my microplastic. On the first 2, I do have a video, but sadly I do not have enough time to show it. This is a copepod, which is the most common zooplankton consuming microplastic. This singular copepod could consume 3 within this control one. This was one where there was no phytoplankton for it to mistake it for. However, in the second one, it actually did mistake some for phytoplankton. As you can see that the microplastic is heavily intertwined within the phytoplankton or plant plankton. There's also some microplastic attached to it. What I actually found to be the most important, what my research found to be the most important was microplastic's ability to latch onto things. So from latching, as I said slightly earlier, there was a slight difference. The mean value between for microplastic latching was 1 and 1.5 in control and experimental accordingly. However, the mean value for being latched to phytoplankton was 64.3, which is an incredibly large number in comparison. This and data show that this is the most significant way in which this microplastic is entering the ecosystem, which is something that can only occur if there is excess phytoplankton. For zooplankton, as you can also see more in the charts, but for zooplankton, I actually incidentally got a demonstration of this ability of phytoplankton to act as a sort of net. I'd say like Velcro, and I'll show you later at the next slide, shows the structure of the microplastic and how that contributes to the netting ability. In the samples without the phytoplankton, there was a mean value of 11.1 pieces of microplastic that would attach themselves to the zooplankton. However, when you took the phytoplankton and you added to the sample, that dropped down to a 4.44. Less than half of the initial, which is very likely due to the latching abilities of the phytoplankton to the microplastic. This is the structure of the microplastic. One example, I use a red soil cup, like I grind it down with a Dremel to allow for better viewing of the structure. And here you can just see how easily it attaches to the phytoplankton. The microplastic has this serrated edge, makes it incredibly difficult to remove from the phytoplankton. And from the zooplankton, it's not as common except for the Cladocera. And as the Cladocera have clumping behaviors, Cladocera are a very common zooplankton. As a clump, it's incredibly easy for this microplastic to get caught within it. Well, sometimes it'll attach itself to the antenna. So in conclusion, my research demonstrated that while it does not have a significant level of change at the consumption level based on how much phytoplankton is present, it does have a significant level of change when it comes to attaching to this, which demonstrates that yes, my hypothesis is supported that excess phytoplankton does increase the rate at which microplastic is cycled into the marine food web. And future studies could either have more tests with the same conditions to establish more statistically significant results, or pursue results at higher or larger trophic organisms to see whether or not it is accurate that this integration would happen at a higher level. And thank you. I'd like to thank everyone at the Ocean Institute for being so awesome, and to my mom for looking over everything, which is great. And he's not here, but special thank you to my friend Patrick, who let me his demo for 2 weeks, and he lent it to me in February, and I gave it back to him in May. So thanks to him, and thank you, everyone.